Hey students, welcome back to Vedantu NCERT Solutions class 11th and 12th. This is Suhas, your chemistry master teacher. Students, in this video, we discuss the solution for the NCERT exercise 7.1 from the unit Redox Reaction. Let's move with the first question. The first question is, assign oxidation number to the underlined elements in each of the following cases. Let's move for the option A. Here we need to find out the oxidation number of phosphorus. Okay, let's choose oxidation number of phosphorus as an X. Okay, what is the oxidation number of oxidation state of sodium? It's an +1. What's about hydrogen? It is also +1, but here 2 molecule of hydrogen is there. That's why it become 2 into +1, right? And what about phosphorus? We don't know. We write as an X. What about oxygen? Oxidation state is -2. O4 is nothing but -8. If we solve this, we got the answer 5. -8 plus 5 is nothing but -5. If we transfer, it is always equal to 0. -5 to this side or LHS to RHS, it's become +5. That's all, +5. Here +5, what's about this? +1, +1, -8 is nothing but 6. What's about this? Here, 7 2s are -14 is there, +4 is nothing but 10. But students, here 2 molecule of phosphorus is there. 2x is equal to +10, x is equal to +5. What's about this? Manganese. Here potassium valence is always +1, is nothing but +2, -8. Manganese is also become +6. What's about this? Calcium oxide. Here we need to find out the oxidation state of oxygen. Okay, 2x is there. 2x is equal to -2. 2 ones are 2 ones are. Oxygen state is -1. Okay. What about this? NaBH4 is there. 4 hydrogen is nothing but +4. This one is +1, right? Barium valence it's become, right? NaBH4 is there, right students? Yes students, here, but here, look here. We already know hydrogen maybe take +1 oxidation state also, either -1 also. But in this compound, it never take +1. Why? It is take -1 here. The hydrogen gain the electron, right? Hydrogen gain the electron. That's why here it become -1. Why? Here already one metal is there. That's why. Okay. Then barium it's become +3. Okay. What's about this compound? Sulfur. Sulfur. What is the valency of sulfur? It must and should be 6, right? 6, 2 +2 minus -O7 is nothing but 14, 12. 2x is there, 2 ones are 2 6. It's +6. What's about this sulfur? This is also +6. Okay, students, I hope it's clear. Potassium is +1, +3, oxygen -8 and 12H plus another is there. If you solve this now, you got the answer. Don't worry. Always it's got +6. Okay, students, I hope it's clear. Any doubt, let me know on comment section. Let's move for the next one. Next one is what are the oxidation number of the underlined elements in each of the following and how do you rationalize your results? Okay, start with here. Ki3. What is the oxidation state? +1. What is the iodine oxidation state? -1. It's become -3. It's nothing but iodine oxidation state, it's nothing but 1/3. It becomes like 1/3. But we already know oxidation state never rationalize, right? It never doing in rational number. It is never rational. It is never obtained in rational form. That's why we can write like this. Okay, this is I2 and I. This is a structure. Minus is there here. Here minus is there. Okay. Second one, H2S4O6. H2S4O6. Okay, H2S4O6. What is the structure of this compound? Let's write the structure, students. OH, then SS compound, and this is a structure. Okay, this is a structure of the compound. But what is the oxidation state of sulfur? Is always +6, right? But if you solve this now, +2. What about this? -12, right? 10. 4 sulfur is there, but it also getting some +8 value. Okay, it also approximately. Here we got +10, right? But students, not in +10, 4x is equal to 10. If we solve now, it got like 2 off, right, students? But we already know the oxidation state is never obtained in rationalized form. That's why we distribute here +5. It is nothing but 2 sulfur have +5 oxidation state and 2 sulfurs have 0 oxidation state. Let's move for the next one. Fe3O4. Iron oxide, Fe3O4. Okay, we can write this as an Fe2O3 and Fe2O. Okay, students, this is a structure. Here we need to different or what is the question? The main question is we need to mention the oxidation number and also we need to rationalize your results. Okay, if we solve now Fe3 we don't know 3x minus 8, 3x is equal to 8, x is equal to 8 by 3. It is also obtained as an what? It is also obtained as a negative rationalized value. That's why it is also never obtained as a rationalized value. Its value is plus 8 is there. That's why it's become here plus 2 and here plus 3. Okay, I hope it's clear. Next, move for the next one. CH3, CH2OH. Okay, CH3, CH2OH. What is the structure, guys? The structure of the compound is this. Okay, alcohol compound, we are already familiar. Okay, let's check the valence. Here we need to rationalize the oxidation state here. Okay, what's about the oxidation state? We don't know the X value. Okay, we don't know the carbon. Plus 1 is there. Oxidation state of hydrogen become plus 1. Okay, totally here also 1 plus 1, totally 3 plus 2 it becomes 5 plus 1 it becomes 6 minus 2 it's nothing but 4. We obtain carbon as an 4. That's why plus 4, right students? Hey students, if we solve now, what we get here, 2x is there. Why? Carbon atom 2 is there, right? 2x is equal to minus 4. X is equal to minus 2. This is an oxidation state. Let's move for the next one. Next one is an CH3COOH. Okay, CH3COOH. Totally 2x, 3 is nothing but 4 minus 4. It's nothing but 0. We got 0. 2x is equal to 0. It's nothing but we got the 0 value. Is nothing but according to this one carbon as an this is an structure, right? This is an structure, one carbon as an plus 2 and another one as an minus 2 oxidation state. That's all. Let's move for the next question. The next question is justify that the following reaction or redox reaction. Okay, let's start with the first one. Students, what is redox reaction? Redox reaction is nothing but oxidation and reduction takes place at a simultaneously. Okay, here what is the valency of carbon? Sorry, not in copper, it's in plus 2, it is in minus 2. Here it's in 0, it's become plus 0. Here copper reduces plus 2 to 0. It's nothing but reduction is happened. What happened here? Yes, it is reduced and here plus 1 it is changes is oxidation state 0 to 1. It's nothing but oxidized, right student? That's why this is an redox reaction. Let's move for the second one. Here what is the oxidation state of iron? It's an plus 3. This one is minus 2. What about here? It's 0. Plus 3 to 0. It reduced, right? And minus 2 to it is minus 4. Okay, 2 molecule is there. That's why it is what is oxidized. What's about this? This is also same thing is happen. B here B2 is happen and here also same thing. That's why it is also a redox reaction. What's about this? Here students, look here. What is the valency of carbon here? Plus 1, right? Plus 1 to plus 1 is there. Plus 1 to 0 is there. Here it changes its oxidation state is that's why it's a redox reaction. I hope same. Okay, I hope it's clear. Same students, here we need to refer, we need to identify. As students, here what happened? Here potassium is not on plus 1, it's on 0. Here it is also on 0, but after here it reduces to, it oxidizes to plus 1, it is reduced to minus 1. That's all students. What's about here? Ammonia, what is the valency of ammonia? According to this, this is on plus 3. Okay, this is an minus 3, this is an plus 3. Ammonia, it is reduced here, it's become plus 2. Okay, plus 2 because oxygen valence is minus 2, right? That's why it becomes plus 2. That's why it get reduced, right? Then here hydrogen, here minus 3 is there, here plus 1 is there, it is oxidized. That's all students. Oxidation number is the increases. I hope it's clear. Let's move for the next one, next exercise. Fluorine reacts with ice and results in the change. Okay, H2O, F2, HF, this one. Justify that the reaction is redox reaction. Okay, here what is the valence of F? It's an 0, right? Fluorine molecule is an 0. H2O here plus 2 something is there, but here let's see, here it becomes minus 1 and it becomes plus 1. Okay, here plus 1, this is minus 2. Okay, plus 1 minus 2, that is equal to fluorine plus fluorine molecule is nothing but minus 1 is equal to F is equal to plus 1. Here fluorine as well as undergo reduction also, fluorine as well as undergo oxidation also. That's why this is an redox reaction. Okay, let's move for the next one. Here calculate the oxidation number of sulfur, chromium and nitrogen and suggest the structure of this compound, count the valency. We need to here we need to calculate the oxidation number as well as we need to suggest the structure and also valency. I hope no question is clear. Let's move for the first one. H2SO5. Let's first check the first count the first find out the oxidation number. Here it is an X, right? X is equal to what is the H2? -2 plus 10 is nothing but 8. Sulfur valency is never 8. That's why sulfur valency is become +6, right, students? Always it is there as an plus. Therefore, here 2 valency is there, students. That's why its structure become like this. What is the structure of the compound? This, right, students? This is an structure. This is an structure. That's why its valency become like this. For these 2 oxygen atom, it has an -1. Then, from according to this, it is also -2. This is 1 plus 1. This is 1 plus 1. Then oxidation state, how it become? Here 2H plus 2, hydrogen has +2, and sulfur we don't know. Oxygen, 3 molecule of oxygen has a -2 valency and 2 molecule of oxygen has a -1 valency. If you do, it becomes 6. I hope here 2 valency is there. What's about second one? Cr2O7 -2. Chromium, right? Cr2O7 -2. Let's find out the, okay, let's check the oxidation state of oxygen, not an oxygen. Total chromium, sorry. 2x plus naught -14, that is equal to -2. It's become 2x is equal to 12. X is equal to 6. The chromium oxidation state become +6, right, students? S, it's become +6. Let's check once S, it's become +6. Therefore, here there is no valency is there. What is the structure of the compound? The structure of the compound become like this. Here double bond O, O minus here -1, it becomes -1. O, here double bond O, and another O molecule. Okay. Here also -1. Okay, students, I hope it's clear. Either or this one. It is -2, -2, -2. Here -2. This is also -2. Okay, let's move for the next one. Last one. NO3 minus. NO3 minus. Students, this is an homework for you guys. Let's tell the valency in the comment section. Let's tell valency. It is very easy. I write the structure also. Okay. It is an structure. O2 minus is there. Minus is there. O2 minus is there. Please tell the valency in comment section. Let's move for the next solution. Okay, next exercise. Write formulas for the following compounds. Okay, mercury chloride is there, nickel. Very easy, students. Let's try. Okay, let's try it. Yes, let's start with the technique and also this one. Here what happens, students? Here, just look here. H2O molecule breaks to form H plus and OH minus, right, student? Here is there H2 molecule and gas. Here H2O molecule breaks to form this one, and also carbon molecules. So carbon dioxide is forms and bond with hydrogen to give this reaction, right, students? This is an oxidation. This one, this is an method to write an oxidation reaction. We need to add the reaction. CO2 H2O is there, then it gives glucose, and this thing is happen. O2 becomes 2 molecule, right, students? This is an answer. Okay, I hope now it's clear. Okay, I hope now it's clear. What happened? This H2 molecule and this molecule get cancelled. Okay, C6H12 is there, 6H2O molecule is there, this H2 get cancelled. Opposite side. Let's move for the second one. Second one, what happened? Oxygen is breaks. O3 molecule break to form an O2 and O molecule. This oxygen molecule is forms and bond with H2O2. Then H2O2 is reacted with hydrogen peroxide, is reacted with oxygen to form water and oxygen gas. Here what happened? Here also oxygen gas is there. Here also oxygen gas is there. That's why these two get cancelled. H2O2 plus O3, it's become O2 is there, O2 is there. This side. It's nothing but in opposite side the molecule is there. We need to cancel this. I hope it's clear. In first molecule, H2O breaks to form in this one. That's why. Okay. This is a method. This is a technique used to write an redox reaction. Next question. Okay. This is a 10th exercise. The compound AgF2 is an unstable compound. However, yes, students, here what is the valency of Ag? Silver. It's an +2, right? Here in the compound +2. It is a very unstable. The compound acts as a very strong oxidizing agent. Why? Because it is very oxidizing. Very unstable compound. That's why it what happened it lose one electron. It accept one electron to become stable. Okay. It is always ready to accept the electron. That's why it acts as a strong oxidizing agent. I hope it's clear. Any doubt, let me know in comment section. Okay, students, let's move for the next exercise. Whenever a reaction between an oxidizing agent and a reducing agent is carried out, a compound of lower oxidation state is formed if the reducing agent is excess. Obviously, correct, right? And a compound of higher oxidation state is formed the oxidizing agent is in excess. Justify this statement giving 3 illustration. Illustration is nothing but we need to explain by using the example. Let's start with first one. Phosphorus and fluorine. Right, students? Whenever the phosphorus is acting as an not a reducing agent, this one is oxidizing agent, we are already familiar. Whenever the reducing agent is correct, right, students? Yes, oxidation state, reducing agent. Whenever first reducing agent is excess, what it form PF3. In this case, phosphorus oxidizing agent oxidation number is +3. Whenever the reducing agent is excess, it form PF5. In this case, phosphorus oxidizing agent is oxidation number is +5. Okay, yeah. Second example, the reaction between potassium and oxygen. Potassium is an reducing agent, oxygen is an oxidizing agent. Whenever potassium is excess, is form KO2. Okay, yeah, so not an KO2, K2O. Sorry for that, K2O, potassium oxide, not an KO2. 1 second. Yes, potassium oxide is formed, not an KO2. Here the oxidation number of oxygen is, what is the oxidation number? -2. Whenever oxygen is excess, it form K2O2, potassium dioxide. Here in this case, the oxidation number of oxygen is -1. Okay, yeah. Last example, best example, carbon and oxygen. Whenever the carbon is excess, carbon is an best example for reducing agent. Whenever carbon is excess, CO molecule is formed. Carbon oxidation number is +2. Oxidation number or oxidation state number. Okay, yeah. Whenever the oxygen is excess, is formed CO2 molecule. Its corresponding oxidation number is increases to +4. Clear? Next question, students. How to count the following observation through alkaline potassium permanganate and acidic potassium permanganate? Both are used as an oxidant set in the manufacture of benzoic acid from toluene. We use alcoholic potassium permanganate as an oxidant. Why? Write a balanced reaction for the equation for the reaction. Because students, whenever we react benzoic acid and form manufacture of benzoic acid from toluene. Whenever we react toluene and alcohol, we yield benzoic acid, right? This is a reaction as benzoic acid by using manganese oxide, KMnO4. Okay, yeah. Why? Because it yield OH minus. Here, look here. While manufacturing benzoic acid from toluene, alcoholic potassium permanganate used as an oxidant due to the given reasons. In a neutral medium, ions are produced in the reaction. Due to that, the cost of which ions produced OH minus ions. The cost of adding on acid or base can be reduced. Super. Second one, all alcohols are homogeneous to each other as they are polar. Polar is nothing but it forms a bond with hydrogen. Okay. Alcohol and toluene are homogeneous to each other because both are organic compound. Reactions can produce at a faster rate there in a homogeneous medium compared to heterogeneous medium. Therefore, in alcohol and toluene can react at faster rate. The redox reaction is given below. This is a redox reaction. Toluene is in the presence of potassium permanganate, it converted into benzoic acid, benzo and minus group, and manganese oxide, H2O and OH minus ions. Next question. Next, another one is also there. When concentrated sulfuric acid is added to an inorganic mixture containing chloride, we get colorless pungent smelling gas, HCl. But it mixture containing bromide. Why? Bromide is a strong oxidizing agent compared to other chlorine molecule, right, students? That's why it forms HBr molecule. Here, look here, reaction is there. Sodium bromide, whenever is reacted with hydrogen H2SO4. It is also an inorganic mixture. This is also an inorganic. This is also an inorganic. What happened? It forms sodium NaHH4 and HBr molecule. Other time it's reacted with H2SO4 to yield bromine gas. That's why it's happened. Similarly, in the case of chlorine or any other halogen, what happened? H2SO4 and NH4. It's yield HCl. Okay, depending upon the oxidizing agents. Very simple. It's an strong. It's an weak. Next question. Identify the substance oxidized is reduced oxidizing agent and reducing agent. Very simple, student. Which substance is oxidized? It acts as an reducing agent. Which substance it's reduced? It acts as an oxidizing agent. Very simple. AgBr. Here AgBr is converted into Ag. what happened here? Oxidation number is decreases. It's nothing but AgBr. AgBr acts as an reducing agent. RS, reducing agent. If it acts as a reducing agent, is nothing but this is an oxidizing compound. This one reducing substance and oxidizing agent. Very simple. In this case, HCHO. HCHO acts as an oxidized substance. It's nothing but HCHO is converted into where? HCOO minus. Yes, students. Oxidized substance is nothing but it's a reducing agent. In this case, this is opposite. This is oxidizing agent and reducing substance. In this case, HCHO Cu2 plus. HCHO, it's an oxidized, it's already done, right? Yes, HCHO and Cu2 plus. Here, Cu2 plus is an oxidizing agent. This one reducing agent. Then opposite, vice versa. What's about this case? In this case, N2H4 acts as an oxidized substance is nothing but reducing agent. This H2O2 molecule, it's an oxidizing agent. It's nothing but oxidized substance. It's nothing but reducing agent. In this case, what is this? Yes, in this case, this is an reduced substance. This is an oxidized substance, PbO2. Next question, students. Consider the reaction. Why does the same reactants, thiosulfates, react differently with iodine and bromine? We are already familiar. Compared to iodine, bromine is a strong oxidizing agent. Okay, for example, in this case, S2O3 2 minus. In this case, its oxidizing number is +2. In this case, S2O3 2 minus. In this case also same, right? Both are same, but here iodine is there, bromine is there. Whenever it's reacted with iodine, it forms S4O6 2 minus. It's nothing but its oxidation number is 2.5. In this case, +6. That's why bromine is reduced from +2 to +6 because it's a strong oxidizing agent. In the case of this, opposite, it's a weak oxidizing agent. That's why. Very simple. Clear? Next question. Justify giving reaction that among halogens, fluorine is the best oxidant and among hydrochloric compounds, hydrohyoic acid is the best reactant. Very simple, students. Justify. Chlorine, halogens, fluorine is the best. F2 molecule is the best, right? Why? Because fluorine have an ability to reduce all chlorine molecule as well as bromine molecule as well as and also iodine molecule. From this, we can write like this. The order is I2, Br2, Cl2, F. Okay. And second question is the hydrophobic compound is completed. Hydrophobic compounds, hydrophobic acids is nothing but HCl, H2SO4. It's an best reductant. Why? In this HCl, H plus ions are formed, right? That's why it's an best reductant. Very simple. Next question. The next question. Why does the following reaction occur? XCO6 minus 2 fluorine molecule 6H plus XCO3 fluorine and it formed this. What conclusion about the compound Na4XCO6 of which XCO6 is a part of can be drawn from the reaction? Okay, student, what is the answer? Look here, students. Here, XCO6 4 minus. What is the oxidation number of this compound? XCO6 4 minus. It is oxidized. It is reduced from. Correct? It is reduced from. Here, oxidation number is +8 to XCO3. Its oxidation state of Xe is +3. Not n +3 +6. Why? X minus 6 is nothing but X is equal to +6. Here +8 is nothing but it is reduced from +8 to +6. In the case of fluorine molecule, it is reduced, it is oxidized from -1 to or it is increased from -1 to 0. Correct? It is reduced to this one, it is oxidized to -1 to 0. That's why it's what conclusion? It's happened. Very simple. It's occur. Okay, now next question. Consider the following reaction. Here what happened? Here AgNO3, you already know this is an oxidizing agent. It forms an Ag molecule. Here also copper molecule also reduces H3PO2. In the case of this C6H5CHO aldehyde molecule is reduced by Ag molecule. It's nothing but both are. By using first reaction, we can easily tell both Ag plus Cu2 plus acts as an oxidizing agents, right, students? Oxidizing agent, but Ag plus oxidizes C6H5CH1 molecule. It easily oxidizes this molecule, but not an this molecule, but not an copper 2 plus molecule. It's nothing but compared to copper, AgNO3 molecule or Ag molecule is a strong oxidizing agent. Very simple. 18th NCERT question 7.18 solution. The question is, balance the following redox reaction by an ion electron method. What is ion electron method? Students, we need to balance the with ion. We need to first write the off reaction, then balance the ions by using electronic and oxidation number. Also, we need to balance, right, students, by using that. First one in basic medium, in acidic medium, in acidic solution, in acidic solution. Come on, let's do. First one. First, we need to write the off reaction given below. Here, first, yes, I minus is converted into I2, right? I aqueous solution is to I2. Reduction of reaction. This is an oxidation of reaction. This is a reduction of reaction. In step 2, balance in oxidation of reaction. If you balance now, 2I minus I2, right, students, add to E minus. Similarly, it happened. Then it's balanced. Next one. Then balance MnO4, reducing agent. Okay, ready. Left hand side of the reaction, then reduction of reaction. Let's take a reduction of reaction. Here add 4 to balance the oxidation number. To balance oxidation number, add 4. Then it's look like this. Okay. Then step 4, balance this one. Then in step 5, add both equation. Then this is an balanced chemical equation by using this. Second question, students. MnO4 minus here. Similarly, first oxidation of reaction, which is oxidation of reaction, this one, sulfur dioxide, whenever it react with water molecule to form HSO4 minus H plus and 2EMN. Okay, similarly, they take redox of reaction, oxidation of reaction is then reduction of reaction, then balance it. You got the answer. Next question. Similarly, same students. Here first write the oxidation of reaction. Iron Fe2 plus is converted into Fe3 plus, add 1 electron. Similarly, here also H2O2 molecule, 2H plus 2 electron, it form an H2O molecule. Then multiply these two equations. Here H2O2 aqueous, 2 Fe2 plus, 2H plus, then it's give 2 Fe3 plus and 2 H2O molecule. Next one, SO2 molecule, 2 H2O molecule, right, student? First write the oxidation of reaction. Oxidation of reaction, SO2 molecule, we need hydrogen H2O molecule, water molecule to convert SO4 minus. Similarly, reduction of reaction, Cl2O7 2 minus, 14H minus, 6H4 minus, it converted into chromium molecule and water. Then write all reaction, add both, you got the answer. Next question. Balance the following equation in basic medium by ion electronic method and oxidation number methods and identify the oxidizing agent and the reducing agent. Here in first example, P4 molecule is reduced to PH3 molecule. It is oxidation state 0 to plus 3, reduced to 0 to plus 3. In the case of OH minus molecule, in the OH minus molecule, P4 molecule is oxidized. It is increased 0 to plus 2. From this, we can easily tell this is an reducing agent, oxidizing agent. Then balancing reaction is take place same one. First write of oxidizing agent, then reducing reaction, then balancing. Final balance reaction I write here, students. This is a final balance reaction. 12H2O molecule, 12HO minus molecule, 12OH minus molecule, that is equal to 8H2 plus 12HPO2 minus. Similarly, this case, this is an omen for you guys. Okay, yeah. Next reaction, next last one. What source information can you draw from the following reaction? Here, look here, CN2 minus. CN2 minus is forming to CN minus, CNO minus. Here, what is the oxidation number of CN2? Here, the carbon oxidation number of carbon oxidation state in CN2 molecule or oxidation number is plus 3. In this case, it's plus 2 and plus 4 respectively. Students, from this, we can easily tell that same CN molecule compound is undergo oxidizing agent also, otherwise it undergo oxidize also, it undergo reduce also. This type of reaction we call disproportion reaction. Disproportion reaction. That is nothing but CN2 is a disproportion substance. Very simple. The manganese 3 plus ion is an unstable in solution and undergoes proportionation to give Mn2 plus, MnO2 and H plus. It's nothing but it give different. It undergo oxidization also, it undergo oxidize and also reduced also. Okay, na? Write a balanced ionic equation for the reaction. How to write balanced ionic equation? We need to write like this. First, the reaction is given below. Manganese Mn3 plus is converted into Mn2 plus, MnO2 H plus. Then first write then oxidation of reaction. Here manganese, what is the oxidation number? 3 plus. Here for the 3 plus 2, 0, MnO2. No, not n 0, is 3 plus 2 minus 4, right? Minus 4, super, minus 4, and also this one add 1 electron to become equal. Then next move on to this one, 4H plus. Here, look here, Mn3 plus is there, here it's not in minus 4 plus 4, it's become plus 4. Similarly, then ion balance the ion, you got this like this. Add 2, add water molecule, then you got this. Then let's move on to the reduction of reaction, Mn3 plus 2, Mn2 plus. Then add 1 electron for reactant side. Then add both equation 1 and 2, write the final equation. This is an Mn3 plus H2O molecule. It's converted into MnO2, Mn2 plus 4H plus. Very simple. Next question. Consider the element CS, Ne, iodine, fluorine. Okay, yeah. Identify the element that exhibits only negative oxidation state. Which exhibit negative oxidation state? Fluorine. Identify. Okay, only negative. Here fluorine. Identify the element that exhibits only positive oxidation state. CS, right? Yes, CS molecule, cesium molecule. Identify the element that exhibits both positive and negative oxidation state. Which exhibits both negative and oxidation state, students? Come on, let us know. It is iodine. For this one, neon. Neon exhibits 0. Very simple. Next question, students. Chlorine is used to purify drinking water. Excess of chlorine is harmful. The excess of chlorine is removed by treating with sulfur dioxide. Present a balanced equation. Correct, Alba? Yes, it's absolutely correct. Chlorine, excess of chlorine is removed by its reacting with sulfur dioxide plus water molecule to yield Cl minus plus SO4 minus. Here we need to mention the balanced final chemical reaction. This is a balanced final chemical reaction. Oxidation. Chlorine molecule SO2 H2 H2O 2Cl minus SO42 minus 4H plus. Very simple. Next question. Refer to a periodic table given in your book and now answer the following question. Select the possible non-metals that can show disproportionation. Okay, disproportionation reaction. Okay, what are the example? We already know phosphorus is give, chlorine and sulfur is give. In the case of metals, manganese also give. In before solution only we already discussed, right, before exercise. And also copper and gadolinium. Okay, yeah, this one. Last question, students. Not a last question, another 5 is there. In Ostwald process for the manufacture of nitric acid, the first step involves the oxidation of ammonia gas by oxygen gas to give nitric oxide gas and steam. What is the maximum number of nitric oxide that can be obtained? Starting only with 10 gram of ammonia and 20 gram of oxygen. They only give 10 gram and 20 gram. Okay, yeah. First write the reaction. The actual reaction is 4NH3 molecule, 5O2 molecule is converted into nitric oxide. 4NO, nitric oxide plus 6H2O molecule. Count, students. Count the atomic mass or atomic number. Okay, atomic mass number. NH3 molecule atomic mass number is 17. 17 into 4, it's become 68. In the case of 160, in this case 120 and 108. These are the few numbers, right, students? We obtained like this. Okay, yeah. Then, what is the main question? We need to find the maximum weight of nitric oxide that can be obtained starting only with 10 gram of ammonia and 20 gram of oxygen. Okay, this is. Whenever take 68 gram of react with 20 gram of oxygen, it obtain totally 23.53 gram of ammonia molecule. Same case, here only 20 gram of oxygen is available, and so oxygen is limiting agent. Now 160 gram of oxygen gives 15 gram of NO. That's why their maximum 15 gram of nitric oxide can be obtained. Only 15 gram of nitric oxide can be obtained. Okay, yeah. Any doubt is there? Let us know on comment section. The question is, using the standard electrode potential given the table 8.1, predict the reaction between the following is feasible or not. First reaction, student, in iron and between iron and Fe3 plus, right? Iron molecule and iodine. Iron is reacted with iodine to form Fe2 plus and I2 molecule. According to this, if you find out the electron E0 value, electrode value, it's 0.77 volt, and this reaction is 0.23 volt. It's nothing but for overall reaction is positive. Overall reaction is positive. That's why it is unfeasible. Next one, between silver and copper, it is also feasible. Okay, why? Because overall, if you find out the electrode potential value, overall is positive. That's why it is also feasible. Next, third one, here negative. It obtained negative and positive. That's why it is not is feasible. Okay, for overall reaction is positive, but here look here. For this, it's not possible. Reaction between iron and copper, it's not possible. It is not feasible. But reaction between iron and copper, it is also unfeasible. Okay, students, I hope it's clear. Next one, it is last one also unfeasible. Okay, yeah, why? Because both the overall reaction is positive. If you find the value, you got the positive feasible reaction only. That's why. Next question. Predict the product of electrolysis in each of the following. An aqueous solution of AgNO3 with silver electrodes. If you do that, the electrode potential value for this one, it's become minus 0.80 volt and also minus 1.23. Then it's nothing but Ag is deposited anode. Okay, yeah. Then an aqueous solution of AgNO3 and platinum electrode. Platinum cannot be oxidized, student, oxidized very easily. Therefore, at the anode, oxidization of water occur. Anode oxidization of water occurs to liberate at cathode. Ag is liberated at cathode. At anode, oxidation of water occurs. In the case of 3, what happened? Hydrogen ions are decreased to H2 gas, and H2O molecules or S442 ions can be oxidized, but the oxidation of S442 minus involves breaking of more bonds that of the H2O molecules. Therefore, S442 minus ions have lower oxidation potential than H2O. Hence, H2O is oxidized at anode to free O2 molecules. Okay, yeah. Then last one. Chlorine Cl2 electron, then it's nothing but chlorine ions are oxidized at anode to liberate Cl2 gas. Very simple. Next question. Arrange the following metals in the order in which they displaces each other from the solution of their salts. It is depends upon the reducing agent. Okay, increasing reducing agent, it easily displaces. According to that, copper come first, then iron, then zinc, then aluminium, then magnesium. This is an order. Next question, students. Given the standard electrode potential, these are the standard electrode potential value. Arrange these metals in their increasing order. Here, minus 2.3 is there, 0.8, 0.7, 0.74 is there. First Ag molecule is coming. Okay, what is the value? 0.80. Next, Hg molecule. Then minus 0.74, not and minus 0.74, it's come as last, right? Potassium. Where is potassium? As potassium comes next, then magnesium, then potassium. Last one potassium, then chromium come first. Chromium, where is chromium, magnesium and potassium? This is an increasing order of the reducing power. Next question. And the last question, student. Depict the galvanic cell in which the reaction takes place. Further show which of the electrode is negatively charged. Very simple. Which electrode? Zinc electrode is a negatively charged. The carries of the current in the cell, Zn2 plus electrode. Then individual reaction for each electrode. In individual, what happens? Zinc in cathode is happen. Zinc is Zn2 plus, it releases 2 electron to form Zn2 plus. In the case of that one, Ag plus, it absorbs 1 electron, or it react with, or it gain 1 electron to become Ag metal. This about redox reaction. If you have any doubt, let us know in comment section. Thank you so much for watching the video, and please do not forget to like the video.